Hi students, welcome to Kiwi Academy. In today's class we are going to see about spherical coordinates. The variables in spherical coordinates are r, theta and phi, where r is nothing but radius of the sphere and theta is nothing but half angle of the cone. And phi is nothing but the angle between x-axis and the half plane. Here next we are going to see how we are going to define the vector. For example, I am going to take a b vector here. Then in spherical coordinates, how we can write this b vector? BR AR vector plus B theta A theta vector plus B phi A phi vector. Here AR, A theta and A phi, these are unit vectors. Okay, so similar to that you can write any of the vector. For example, I am going to take d vector is equal to 8 AR vector minus 6x A theta vector plus 7 y squared A phi vector. So here how you write this coordinates? This 8 is nothing but dr. This minus 6x is nothing but d theta. And here 7 y squared is nothing but d phi. Okay, so this is the thing how we are going to define the vector. Next we are going to see the range. Next we are going to see the range of these variables. Range of variables. Here r varies from 0 to infinity. R varies from 0 to infinity. And theta varies from 0 to phi, 180 degree, because half angle of the cone. Okay. And next phi varies from 0 to 2 phi. So you want to remember one thing. In spherical coordinate system we are having two angles. One is theta and the another one is phi. And now we are going to define the sphere by means of these three variables. See, sphere is a three-dimensional image: x-axis, y-axis, z-axis. Okay, here I am going to consider a cone. And again I am going to consider a half plane. Here this cone and this half plane, where along is going to form a sphere. Consider like this. This is a half plane and this is x-axis and this is y-axis and this is z-axis. Okay, this cone along with the half plane we are going to form a sphere. Okay, so this particular angle is phi and the half angle of the cone is theta and the radius of this sphere is r. This is r. Okay, and this r is nothing but lateral side of this particular cone. Okay, so this side, what is the value of this side? Consider this particular triangle. This side is r. Okay, this side I don't know. okay, and this side is nothing but z axis. Okay, so this angle is theta. How you are going to find this opposite side of this particular angle? So we want to consider sine theta. Sine theta means opposite side by hypotenuse. So for this particular triangle, what is the opposite side of this particular angle? What is the opposite side? Yes, I don't know. Question mark. Divided by hypotenuse, that is r. So what would be the question mark? R sine theta. Yes. So here this value of this side is nothing but r sine theta. So this particular side and this particular side are parallel. This is nothing but what? A plane. Okay, a half plane. So here this is r sine theta means this would also be r sine theta. So this particular side is nothing but r sine theta. Okay. Okay. Then what I'm going to do is I'm going to consider this particular triangle by joining this line. Okay. So see here, while considering this particular triangle, yeah, I know this side, which is our sine theta. Please don't consider this. Don't consider this line. So what is this? This is nothing but the line which is parallel to y-axis. See here, y-axis, parallel to y-axis. So this would be y. And this particular side is nothing but in x-axis. So it is nothing but x. So if you want to find the value of x means, you want to consider this triangle, and if you want to find the value of y means you also want to consider this particular triangle. Okay, so here I am going to take cos phi. So cos phi means, what is the formula for cos phi? Yes, adjacent side by hypotenuse. For this particular triangle, this hypotenuse, and this is the side which is adjacent to this particular angle. Adjacent side is x, and the opposite side which is opposite to this particular angle phi is nothing but what? The side which is opposite to this angle is nothing but y. Okay, so see here I am going to consider cos phi. So what is the formula for cos phi? Adjacent side by hypotenuse. Adjacent side is x, hypotenuse nothing but r sine theta. So what is the value of x? X is equal to r sine theta cos phi. That's all. Clear? So yeah. So see here, next I am going to consider sin phi. I am going to take sin phi for this particular triangle. So see here, this is hypotenuse, r sin theta, this is adjacent side, this is opposite side. So what is the formula for sin phi? Opposite side divided by hypotenuse. Opposite side for this particular triangle is what? Y. So y divided by hypotenuse is r sin theta. So what is the value of y? Y is equal to r sin theta sin phi. Yes. So I am going to consider, I have found out x and I have found out y. Next what I want you to consider, what I want to find out is z. So how? If I want to calculate z means I want to go for the upper triangle, because x-axis is in the upper triangle, not in the lower triangle. See here, we are going to consider two triangles. One is upper triangle and the another one is lower triangle. By using this lower triangle, you are finding the values of x and y, and by using the upper triangle, I am going to find the value of z. So see here, I want to find the value of z for this particular triangle. Yeah, this side I know, this is hypotenuse r, and this is adjacent side for this particular triangle. What is the adjacent side? Yes, z is the adjacent side. And what is the opposite side? Yes, r sin theta. If I want to find the value of z in terms of theta, what I want to do? I want to take sin theta, otherwise cos theta. Yes, I want to take cos theta, right? Why I am taking cos theta? Because the formula for cos theta is adjacent side by hypotenuse. Adjacent side is Ez, hypotenuse is R. So if I want to find the value of Ez, so I am writing here. So if I want to find the value of Ez in the upper triangle, here for x and y you are considering lower triangle, right? So upper triangle cos theta, see here the angle is theta, okay? So in upper triangle you are taking, means you want to take cos theta is equal to adjacent side Ez divided by hypotenuse R. So Ez is equal to R cos theta. That's all about this. So x, y, z. See, x, y and z. X, y and z were variables of Cartesian coordinates. R, theta, phi were variables of spherical coordinates. Here what I am doing? Here I am transforming. Spherical coordinates to Cartesian coordinates, okay? If in your hand you are having the values of r, theta and phi, means you can able to find the values of x, y and z. Yes, that's all. And again we are going to see how we are going to transform from Cartesian to spherical. See here x, y, z I am finding is from the values of r, theta and phi. If you are having the value of r and theta and phi, means you can able to substitute in this formula and you can able to find the values of x, y, z, right? So this is nothing but transformation from spherical to Cartesian, right? If you are having the points r, comma theta, comma phi, means you can able to substitute in this formulas and you can able to find x, y and z, okay? So again we are going to see transformation from Cartesian to spherical. If you are having from Cartesian, if you are having in your hand, you are having x, y, z, and how we are going to find the values of r, theta and phi? Yes, it's very simple. The value of r is nothing but square root of x squared plus y squared plus z squared. This I am going to prove, okay? So you are having the values of x, y, z. By substituting those values in this particular formula, you can able to find the value of r, which is variable of spherical, okay? So this I am going to prove now. So what is the value of x? X squared plus y squared plus z squared. Here we are going to take, okay? And what is the final value? It would be r. That I am going to prove here. So x value is nothing but r sin theta cos phi. So r squared sin squared theta cos squared phi plus again y squared. What is the value of y? Y is this. So y squared is r squared sin squared theta sin squared phi plus again what is the value of ez? Yes, z is equal to r cos theta. So z squared is r squared cos squared theta. So among these two I am going to consider the values. I am going to separate r squared sin squared theta, which is common in these two terms. So what would be inside? Cos squared phi plus sin squared phi, okay? So plus r squared cos squared theta. Here the value of cos squared phi plus sin squared phi is 1, we know, okay? So r squared sin squared theta plus r squared cos squared theta. Again I am going to consider r squared is common, sin squared theta plus cos squared theta. So finally r squared, so x squared plus y squared plus z squared is equal to r squared. Then what would be r? Yeah, we want to take square root on both sides. So x squared plus y squared plus az squared. That's all. So we have found out the value of r. Next, what we want to find? We want to find the value of theta. So we want to find the value of theta. It's very simple. See how we can able to find the value of theta. So cos theta is equal to z by r. By the upper triangle we know what? Cos theta is equal to az by r. From the upper triangle we know cos theta is equal to z by r. Then what would be the value of theta? Cos inverse of z by r. That's all. This is the value of theta. So see here, we are having z value, and instead of r you want to write what? You want to write the value of square root of x squared plus y squared by plus z squared, because you are having only the values of Cartesian. In the right hand side it only consists of Cartesian variables, which are x, y and z. See, x, y and z only exists. If in my hand I am having Cartesian variables x, y and z, means by substituting those values in this particular formula I can able to find the spherical variable theta. Yes? Okay. Then how I am going to find the value of phi? So for phi, see here, phi, by considering this lower triangle, I want to find the value of phi. Means what I want to take, what is opposite side y and the adjacent side x. So by taking tan phi, opposite side by adjacent side. Okay, by considering the lower triangle, see here, by considering the lower triangle, this, right, x, y, this is phi, and this is what? Yes, r sin theta. So tan phi means opposite side y by adjacent side x. So what is the value of phi? Tan inverse of y by x. That's all about the transformation from Cartesian to spherical. See, what is the value of r? R is equal to square root of x squared plus y squared plus z squared, and theta is nothing but cos inverse of z divided by square root of x squared plus y squared plus z squared, again phi tan inverse of y by x. So right, this is formula for transformation from Cartesian to spherical. Cartesian variables I am having in my hand. I am having the value of x, y and z. By substituting those values in this particular formula, see, in right hand side it consists of only the Cartesian variables x, y and z. By substituting these x, y, z values in this particular formula, I can able to find r, theta and phi. These are variables of spherical coordinates. So transformation from Cartesian to spherical, right? So next, one important thing I am going to teach you, that is nothing but differential elements. I have already taught you differential elements for Cartesian and cylindrical, right? So, right students, differential elements. So first one is differential length. Here you want to note one point. dl vector is equal to dr ar vector plus what is the next unit vector? ar, a theta, a phi. But you want to note one point, you want to keep one point in your mind. In spherical coordinates, theta and phi both are differential angles. D theta means differential angle, d phi means differential angle. If you want to consider differential length, you want to multiply that particular angle with some value. So far, see here, See here, the r is not alone, it's always varies depending upon the value of theta. So you want to consider here r hereafter does not comes alone. Dr does not comes alone. Dr does not comes alone. It always, sorry, d theta does not comes alone. Sorry, d theta does not comes alone. It always comes along with r. D theta comma r were friends. Hereafter d theta does not comes alone, it comes along with r. Okay, so similar to that, see phi. So d phi always changes with respect to r sin theta, while this particular plane rotates. It also varies the angle of phi. So d phi does not comes alone, it always comes along with r sin theta. So please keep this point in your mind. Okay, now come here. So how you are going to write the differential length? I have already tell you now. D theta, a theta vector, but d theta is differential angle. Now we are writing differential length. It comes along with d theta, always comes along with what? D theta does not comes alone, because it is differential angle. You need differential length means you want to multiply it with r. Similar to that, d phi does not comes alone, it always comes along with r sin theta. So right here d phi or d theta and d phi, a phi vector does not comes alone, it comes along with r sin theta. That's all about differential length. Dr is nothing but differential length in r direction. Please note it, dr is nothing but differential length in r direction. R d theta is nothing but differential length. D theta alone differential angle, but r d theta is differential length in theta direction, and r sin theta, d phi is nothing but differential length in phi direction. So similar to that, we are going to write differential surface. So here there are three surfaces are possible: ds r vector, ds theta vector, and the last one is ds phi vector. I have already taught you in Cartesian and cylindrical itself what is in the subscript. You want to take that as unit vector. You are very correct. Unit vector, ar vector. Among r, theta and phi, here r comes as unit vector. So what are the remaining two? Theta and phi. Yes, then how you are going to write this? D theta, d phi, but d theta does not comes alone, d phi also does not comes alone. Theta comes along with r and d phi comes along with r sin theta. So already r is there, sir. R squared sin theta, that's all. So r s theta vector is equal to, here I am going to take theta as unit vector, a theta vector. So cancel this. What are the remaining two? R and phi. So how we are going to write? Dr d phi. Right, very good. Dr d phi, but d phi does not comes alone, comes with r sin theta. Again ds phi vector. So what is the unit vector? A phi vector. So cancel this. Dr d theta. Dr d theta. Sorry, you want to maintain the order. R theta phi. Dr d theta. Theta does not comes alone, it comes along with r. Put that r here. Right, this is the differential surface, and the last one is differential volume. So you all may know, you all already know that differential volume is a scalar quantity, otherwise vector quantity. Watch. See here, length is vector quantity. In meters we are measuring the length, and surface we are measuring that in meters squared. Okay, it is also vector quantity, but weight, volume means nothing but weight. It's a scalar quantity. So dv is equal to dr d theta d phi. You want to maintain the order, or theta phi. So d theta does not comes alone, it comes with r, and d phi also does not comes alone, it comes with r sin theta. Already one r is there, so r squared sin theta. Unit of this is meter cube, and unit of the surface is meter squared, and unit of the length is meter, right? This all about spherical coordinates. That's all. So see here, let me consolidate. So what we have seen so far in spherical coordinates, what are all the variables? Yeah, in spherical coordinates, what are all the variables? R, theta, phi. Want to maintain the order. Okay, unit vectors, R vector, A theta vector, A phi vector. And again, how can we write the vector? I have taught you. And what are all the ranges of these variables? I have taught you. And how we are going to consider the sphere as three-dimensional image. A cone along with the half plane rotates very fastly, means it would appear like a sphere. Okay, so here we are going to consider lower triangle, and here we are going to consider upper triangle. By means of these, we have also seen the transformation, and afterwards what we have seen, differential elements. Yeah, thank you my dear students. See you once again with yes very nice video. Thank you.